What's up, YouTube? This is Martian. Today we'll be going over Advent of Cyber Day 9, which covers malware analysis. The learning objectives here are the foundation of analyzing malware samples safely, the fundamentals of .NET binaries, using the DNSpy tool for decompiling malware samples written in .NET, and building an essential methodology for analyzing malware source code. So pretty much in this lab, we are doing a static analysis of the malware sample. This means we are not executing it at runtime to see what it does to the system. So in most cases, when you get a sample in the field, you would have to get the sample after it is already compiled into a running program. But in this case, we are going to do static analysis of malware that was written in .NET, which means we have to know a bit about the intermediate language via the CLR, which is essentially a translator. The intermediate language is more straightforward than trying to analyze the machine level code that is normally used in malware. So let's go ahead and open up DNSpy in our program here. Let's see. Go in here. So we have our sample juicy tomato. Let's open that up with DNSpy. I can just drag and drop it into DNSpy directly. And we have our program loaded now. So here we have our PE section, which is the executable portion up top. But we need to take a look at the actual source code, which is down here. So we have the program source code here. This is where we want to analyze the malware via static analysis. So let's take a look at the different functions. Just in my window. So first things first, we have decryptor. Looks like the decryption key or an encryption key here is you can't hack this super secure 2 keys, which is connected to the encryptor performing basically AES encryption, looks like. So we have that AES encryption right off the bat. So just going through, if we go through execute command, here it's just running the command prompt. Yep, running the command prompt on the C drive. We have get it with a user agent. So we have a get request across the web. So this is mostly just, boilerplate user agent header. Usually if you send a request across the web without a header, this would be picked up as a bot right off the bat. So you have to add a user agent of some sort to your web requests. So inside of implant, we have the code that uses the get it function inside of the program in order to receive data from a URL and convert it from base 64 into a byte array. After that, it writes those bytes into the application data folder spykit.exe program. Let's take a look at Post-it real quick. So inside of Post-it, this looks like where the program is posting information to a URL, or in this case, the malicious web server. Let's check Sleeper. Okay, so Sleeper is pretty much the program that makes it stop for a set amount of specified milliseconds. This is where the C2 agent sleeps and wakes to check for any new commands to run on the target's system remotely. And last but not least, we have main. So in the main function, we have a string that indicates the URL of MacGreedy secret C2. This is our C2 server, and it adds it to the /reg, which is probably the registry. It then takes the host name and posts it to a parameter in that location. Here is where the sleeper method is used in the count section, and in this case, it represents 15,000 milliseconds, which is 15 seconds. This means the agent will sleep every 15 seconds. Scrolling down. Okay, so here we have a for loop. So this for loop is set up in a way to do this until it can't anymore, basically. So inside the for loop, we have URL2 as a string. We have /task/results. This means send those commands to the C2 URL /task endpoint or the /results endpoint after the agent wakes up to check for any updates. If the string is not null or empty, it will check to see the value of the string that was sent. So here's where the attacker has their options for what can be staged on the agent, which are sleep, shell, implant, and quit. So this is set up so that when the C2 agent checks in and looks for any new commands in either of these categories, it will basically perform this action. So pretty straightforward. This is easier than, going to byte level or machine level code because of that high level language it was written in. Keeping that in mind, this sample is pretty straightforward. Taking a look at that, it's written in C#. So let's head back to the challenge over here. So handling a malware sample is dangerous. Always take precautions during your analysis. So in this case, we were provided a machine to actually, handle the malware in, but it was also not at runtime. So either way, you want to make sure that you are properly sandboxing any malware samples you run across. Let's scroll down here to check out the challenge. Pretty straightforward. Feel free to go through and do the task and get more details. Right now, what I'm doing is just a walkthrough. So here we have the challenge questions. What HTTP user agent was used by the malware? So that should have been in the post-it method. Yep. So yeah. So as I stated before, having that user agent. Let's see if we can get that over here. There we go. So what is the HTTP method used to submit the command execution output? Yeah, that's more than likely going to be a post request in almost every case. What key is used by the malware to encrypt or decrypt the C2 data? So it's going to be the same key since it's AES encryption. So pulling this out of the encryptor function or the decryptor function, it's going to be the same key. What is the first HTTP URL used by the malware? So go into the main function and we have our C2 server. But that's not the final URL. The endpoint is /reg. Good to go. So how many seconds is the hard-coded value used by the sleep function? So heading over to sleeper, or actually heading over to main, and we have this count. So 15,000 milliseconds is 15 seconds. Here we have what is the C2 command the attacker uses to execute commands via cmd.exe. So we can head over to execute command to see what that is. So execute command is indeed cmd.exe on the root drive. So we can only do that with the shell command here. Typing in shell. Here, lastly, we have what is the domain used by the malware to download another binary. So we have sleep, shell, implant, and quit. But if you know anything about the attack methodology, you would know that implant should be where we perform post exploitation if you're watching any malware activity. So implant is this function here, but this is where it's going to go to spykit.exe. The question being asked here is, what is the domain used to retrieve that? So down here inside of implant, we have stash.mcgreedy.thm. And that is the actual domain where it is being hosted. And that's pretty much it. So this was written in a high level language to where we can pretty much understand it. In other cases, you would have to get to the byte of machine level code to get it figured out with a debugger. But that's it. Feel free to go through the challenge and get a deeper level understanding. See you next time.